This is the second part of adding and subtracting polynomials. This is the second day of the lesson. We are going to continue with the same objectives. This is just a review from the first day. So lesson objectives, what students will be able to, and all these points students will be able to do in this lesson. And focus, same focus, new vocabulary are closure property, degree of a monomial, degree of a polynomial, monomial, polynomial, and standard form of a polynomial. In this lesson, you will be able to solve adding polynomials. The essential question is, how does adding or subtracting polynomials compare to adding or subtracting integers? Now let me put in Spanish version the problem.
A. ¿En qué se parece la suma de polinomios a la suma de números enteros?
How is adding polynomials like adding whole numbers?
Okay, let's see the solution, how adding polynomials is like adding the whole numbers. Now, consider the expression 123 plus 405 and x squared plus 2x plus 3 plus 4x squared plus 5. So how do we add this? Now, as you have learned in previous skills how to add expressions or numbers, how do you add them? So vertically, this is adding them vertically, and the expressions, combining both these two expressions, adding them vertically. As you see now, we do in the first expression only like place values can be added. In the second expression only like terms can be added. Before you add polynomials, the terms must be aligned with like terms. As you see here, x squared is a like term with 4x squared, so these have to be combined, so we have to put under each other when we add them vertically. 2x, do you see 2x? 2x doesn't have any friend, doesn't have any like term, so we leave it like that. Plus 3 and positive 5 is a like term. We combine positive 3 and positive 5. So we just put positive 5 under positive 3. Okay. Let's move to the next one. Let's see another example.
Parte B. ¿Cuál es el resultado de la suma de 4 por x al cuadrado, más 2 por x, menos 3 y 3 por x al cuadrado, más 6?
What is the sum of the quantity 4 times x squared plus 2 times x minus 3 and the quantity 3 times x squared plus 6?
Okay, we're going to introduce two methods how to add these polynomials. The first method, it tells us that adding them vertically align like terms. As you saw in the first example, we align like terms. In this example, 4x squared and 3x squared, they're both like terms because they have same variable, they contain same variable with the same exponent. Now, positive 2x has no like term, but negative 3 has like term, positive 6, so we align under each other. And the answer is 7x squared plus 2x squared plus 3. Method number 2. Method number 2 is to add them horizontally. What do we do when we add them horizontally? We use the commutative and associative properties to group like terms. For example, 4x squared and 3x squared are like terms, so we combine them. in the parentheses plus 2x doesn't have any like term, but we leave it alone, plus negative 3 and positive 6 are like terms, so we group them together. Same as we did vertically, but we're doing this process horizontally. Whatever works for you, you can do it. Now, and the answer is the same, 7x squared plus 2x plus 3. So the sum of 4x squared plus 2x minus 3 and 3x squared plus 6 is 7x squared plus 2x plus 3. The sum of these two polynomials is a polynomial. As you see, we had sum of polynomials and it gives us a sum of a polynomial. So it's 1 term, 2 term, 3 terms, so the 3 terms. What do you have to pay attention to this is that when you align like terms, when adding polynomials vertically, you do have to put the numbers of like terms under each other as they combine to each other. Okay, this is, I'm not gonna give you this, but this is going to be as your classwork. We're going to post this in Google Classroom, so you'll be solving both these polynomials. You're simplifying, write each answer in a standard form. Simplify. First step to do, I'm going to give you a hint about this. First step you do, you get rid of parentheses, and then you you combine like terms if you find any, and then you put them in a standard form in an ascending order from the greatest exponent to the smallest exponent. Let's see now, example 5. Let's go with example 5. Example 5. Subtract polynomials. Subtracting polynomials is similar to adding polynomials. Let me translate this in Spanish version.
¿Cuál es la diferencia de 6 por x al cuadrado más 3x menos 2 menos 3x al cuadrado más 5x menos 8?
What is the difference, the quantity 6 times x squared plus 3 times x minus 2 minus the quantity 3 times x squared plus 5 times x minus 8?
Okay, let's see these two quantities. So as I said, use same strategies, same methods as we did with adding polynomials. The first method will be subtracting them vertically by lining up like terms. Now, the point is here that we are using parentheses, but when we get rid of parentheses, you have to pay attention to distribute -1 to each term. So as you see here, in front of this parenthesis is negative sign, but there is an invisible 1. So this should be -1. We are multiplying -1 to each term inside, and we get -3x squared, -5x. You see, as you see here, is changing the sign because negative times negative gives us positive, and negative times negative, it gives us positive, and it gives us 8 plus. And when we subtract them, we go step by step. -2 plus 8 is +6. +3 minus 5x is -2x. And 6x squared minus 3x squared is 3x squared. Let's see now method 2, subtracting them horizontally. It's the same thing as we added horizontally. By distributing negative, in this case, we're distributing -1 to each term in the subtracted expression. As you see here, if we can write something here, it's going to be -1. So when you distribute this becomes -3x squared, -5x squared, and +8. Now in the third row, 6x, we combine like terms. How do we combine like terms? So 6x and 3x squared and negative 3x squared are like terms because they have same variable and they contain same exponent. So we can combine them, and 3x and negative 5x, they have same variable and it contains with same exponent, which is 1. And the negative 2 plus 8 are the constant. And the final answer is equal to 3x squared minus 2x plus 6. So the difference of 6x squared plus 3x minus 2 and 3x squared plus 5 minus 8 is 3x squared minus 2x plus 6. The difference of these two polynomials is also a polynomial. The result of adding or subtracting two polynomials is another polynomial. The closure property states that polynomials are closed under addition or subtraction because the result of this operation is another polynomial. So this is the definition of closure property. Let's take a look about the common error. Common error should be about distributing. So remember that subtraction is adding the opposite of every term in the second polynomial by distributing negative to each term. So this is very important point. Distributing negative 1 to each term. Let's move to the second, and this is also going to be like your classwork or going to post in Google Classroom, and you'll be answering these two questions. Let me go to example 6, example 5, additional example 5, additional example 5, try 1, okay? In example 5, use the three polynomials below. P 9x cubed minus 9x squared minus 9x minus 5. Q 8x cubed minus 8x squared minus 3x minus 3. And R 4x cubed minus 2x squared plus 5x plus 8. A. Find R minus Q by lining up terms vertically. This is specific question, so we are subtracting R minus Q and we are solving by the first method, lining up vertically. Question B, find P minus R, so P is here, this expression, minus R, by lining up terms horizontally. Let's take a look now. We have two methods to solve both of these. A. So we are using this, we are solving this polynomial, by lining up vertically. Okay, minus, we're using subtraction. Again, we are using negative, distributing by negative 1. And B, we are we're doing them vertically, horizontally, using the associative and the properties that you have been learning in the previous slide. So take a look how this is done. Let's go to next example, which is example 6, apply polynomials, and I'm going to wrap it up with this. So this is a lot to cover, but okay, I'm going to read it because
An engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of the farm's solar panels?
Let me translate this in Spanish so you have a better understanding of Spanish words.
Un ingeniero revisa el diseño de una granja solar. La granja solar tiene 4 paneles pequeños, 33 medianos y 32 grandes. ¿Cuál es el área total de los paneles solares de la granja?
Okay, use a structure. So using a structure, how could you use what you know about polynomials addition to find an expression for the area of each small solar panel? Let's take a look now. Let's see the solution. What's the solution will tell us about this problem. Write an expression to represent the total area of the solar panels. Use the commutative and associative properties to group like terms, then add. Okay, since we have the area, total area is going to be equal to total area of large panel plus total area of a medium panel plus total area of a small panel. As you see here, you have the total area of the large panels, total area of small, total area of the medium. We're going to add them up to find the total area. So since we have the information, all the expressions, they're here, so the areas, the expression, we add them together. Now, the next step is going to be to combine in like terms. So you're adding them horizontally. So 32x squared and 33x squared are like terms because they have same variable and they contain with the same exponent. And 4x squared, so there are three like terms together, plus 384x plus 272x plus 24x. Both these terms, they have same variable with the same exponent, which their exponent is 1. And the total area is 69x squared plus 680x. So the total area of the solar panels is modeled by the expression 69x squared plus 680x, where x is the width in meters of each solar panel. Okay. Let me go next. And next should be the other example, which this is going to be for you in Google Classroom to solve. It's similar to the previous one. I'm going to wrap it up here, guys, and I hope you're learning and progressing through remote learning. Bye.